guys, in this video I'm going to be taking a look at one of the special forms of quadratics, the difference of two squares. Now the difference of two squares tells us that if we multiply something together, such as a plus b times a minus b, then we are always going to get a squared minus b squared. But let's see how that's true. So let's say we want to expand these two. I'm going to use the table method for expansion. So put the a and a positive b across the top, a and a negative b down the side. Then the a times a is going to give us a squared, a times b is going to give us ab, minus b times a will give us minus ab, and then minus b times positive b will give us minus b squared. So if we take all of that out of the table, we've got a squared plus ab minus ab minus b squared. So these two chaps here in the middle cancel each other out, and we just get left with a squared minus b squared. So we're first of all going to have a look at expanding difference of two squared brackets, and then we'll have a look at factorising them. Before we get there though, why is it called the difference of two squares? Well, a squared is a square number, b squared is another square number, and we always end up with a squared minus b squared. So, whenever you're playing with subtractions, a subtraction is finding you a difference between two things. So, we're finding the difference between a squared and b squared. Okay, so let's have a look at expanding some of these brackets. So, x plus 3 times x minus 3. Well, that's going to give us x squared minus 9. So you always get the first term in the bracket squared minus the second term in the bracket squared. So 2x plus 1 times 2x minus 1, that will give us 4x squared minus 1. Now we can't even use this for surds, and we do use this for surds. Sometimes when we need to rationalise denominators, we will come across multiplications like this: root 3 minus root 3 minus root 2 times root 3 plus root 2. So if we expand that out, we get root 3 squared minus root 2 squared, which is going to be 3 minus 2, which is going to be 1. What about 2 minus x times 2 plus x? Well, that's going to give us 4 minus x squared. And then 5x plus 3y times 5x minus 3y. Well, 5x squared is 25x squared. 3y squared is 9y squared. So we get 25x squared minus 9y squared. So that's how we multiply brackets when we're dealing with difference of two squares situations. You can of course use your normal technique for expanding the quadratics, but if you can spot that it's a difference of two squares, it will speed things up quite a bit. So what about factorising then? So all of these here are examples of differences of two squares. Now this comes in really handy sometimes for simplifying algebraic fractions. Sometimes you might even just be given a quadratic that is a difference of two squares, and you would just be asked to factorise it. So how do we spot that we've got a difference of two squares? Well, we will always have an x squared term first. So it might not be a singular x squared term. If it's got a number attached to it, that number will be a square number. So if we look at some of these examples, we've got a 25x squared, a 4x squared. And then we've always got a subtraction, always a subtraction. If it's an addition, there's nothing we could do. And then the number that we're taking away at the end will always be a square number as well. So we never ever have an x term. We always have an x squared term and just a number term. So let's have a look then at how we would factorise these bad boys. So x squared minus 4. Well, the square root of x squared is x. So we're going to have an x in its bracket, then we're going to have a plus or minus, and then the square root of 4 is 2. So x squared minus 4 factorizes to x plus 2 times x minus 2. X squared minus 1, again the square root of x squared is x. We need a plus and a minus, and then the square root of 1 is 1. So we've got x plus 1 times x minus 1. Cool. 25x squared minus 9. So the square root of 25x squared is 5x. And then we need a plus and minus. And the square root of 9 is 3. So 25x squared minus 9 factorizes to 5x plus 3, 5x minus 3. Okay, 64x squared minus 1. Remember, if you want to have a go at any of these first, pause the video. So the square root of 64x squared is 8x. Plus and minus, and then the square root of 1 is 1. Happy days. 4x squared minus 49. Well, the square root of 4x squared is 2x. Whack in our plus and minus, and then the square root of 49 is 7. Cracking. 81x squared minus 144. Well, the square root of 81x squared is 9x. Whack in the plus or minus, and then the square root of 144 is 12. So we get 9x plus 12 times 9x minus 12. 9 minus x squared, so slightly different here. The x squared term is the one being subtracted. So the first term in each of our brackets for this bad boy is going to be the square root of 9, which is 3. Then put in our plus and minus, as always, square root of x squared will just give us x. So 9 minus x squared factorizes to 3 plus x times 3 minus x. Okay, and then the final example, 25y squared minus 16x squared. Okay, so it probably looks a little bit scary, but let's not let it be the boss of us. The square root of 25y squared is 5y. And then the square root of 16x squared is 4x. So, each of our brackets, we're going to have 5y plus 4x times 5y minus 4x. Okay guys, that's how to expand and factorize difference of two squares quadratics. Hope it's useful. Was this video helpful? If so, be sure to leave a thumbs up and a comment telling me how you get on. For any further information, you can follow me on Facebook and Twitter, and send requests or any feedback you have. Search for Maths with Mouth. Cheers guys.